Welcome again to this video. So in this video, we shall show how we derive the optimal or Marshallian demand function of a consumer using the Equi-Marginal utility approach. So again, assume a consumer with utility function given as uxy is equals to x half plus y. So, and phases prices px and py for good x and y respectively. So given our income, we assume to know we want to know the mix of x and y that optimizes our utility. So in this case, solution, we are not using the Lagrangian approach. So if you want to learn the Lagrangian approach, look at the other video on the YouTube page. So in this video, we look at Equi-Marginal utility. So the Equi-Marginal utility approach states that the marginal utility of x by its price should be equal to the marginal utility of y by its price, or the marginal utility divided of x over y is equivalent to the ratio of prices. So where MUX is simply the differential of u to expect x, which is equal to marginal utility of both x, and marginal utility of y is differential of u to expect y. So for differentiate marginal utility of to find marginal utility of x, we differentiate u to expect to x. But mind you, this is x half. So if you differentiate x half, you have the half coming down. X half minus 1 equals to x minus 1 over 2 all over 2 is equivalent to 1 all over 2x half. So the marginal utility of y is equals to the differential of u to expect to y. It gives you 1 because y just having a power of 1 there. So we want to plug both of these, since we have the marginal utility of x now and the marginal utility of y. We want to plug both of them into the formula. Precisely, we use this one. It's quite easier to use, but both of them gives you the same answer. So marginal utility of x is this, divided by 1, which is the marginal utility of y, all equals to px over py. So, but we know division on division turns to multiplication, but this is simply 1 over 1, so it still remains 1, equals to px over py. Once again, the marginal utility of x divided by the marginal utility of y, which is 1, equal to px over py. So you have 1 all over 2x half times 1 equals to px over py. So 1 times 1 is just 1. 2. So you just have 1 over 2x half equals to px over py. So you cross multiply. Py times 1 gives you py. 2 times this gives you 2px x half. So by cross multiplying. So you have 2px x half equals to py. But we are finding x. So we solve for x since we are finding x here. So you simply, mind you, there is nothing like y anymore. So whatever function of x you have will be the Marshallian demand function for x, since there is no y anymore here. So you divide both side by 2px. So 2 cancels 2. Px cancels px. So what remains here is x half equals to py over 2px half. So if you want to eradicate this half, what do? We simply square the on both sides. We'll take the square on both sides. So this cancels this. So this is 2. So therefore you have x Marshallian now, xm, will be equals to py over 2px all squared. So py raised to 2 gives you py squared. 2 raised to 2 is 2 times 2 gives you 4. then px raised to half. So this is a Marshallian for x. So we want to know why, because we are not complete yet. So we want to derive the Marshallian of ym. So next we substitute x Marshallian into a budget constraint to find Marshallian of ym. So the budget constraint is m equals to pxx plus pyy. So but x Marshallian is py square over 4px square as we derived earlier. So but remember the budget constraint is this. So where you see x, you substitute this here. So it gives you px py square over 4px square plus pyy. But this is px divided by px square. So what happens? This cancels one of the px, because this is like px. It's like you having px times px. So it's like this. This is the same as this. So this we cancel one. So it remains px. That's why we have px here. So you have m equals to py square over 4px plus pyy. So pyy is equal to m minus py square over 4px. So if you divide 2 by py, why do we do that? We transpose this. I will transpose this to this. So if it goes to m, it becomes minus. So you have pyy equals to m minus this. So this minus this gives you this. But our focus is on deriving y, not py. So you divide both sides or throughout by py. So you divide here by py cancels py. So this is m over py. Then this again divide by py. So it gives you this. Division on division, it turns to multiplication. So this becomes 1 all over py. But this py we cancel py just for similar reason as we did. Yeah, it cancels. So what remains is m over py minus py over 4px. So in this case, our Marshallian demand function for y is finally 4pxm minus py square. But how did we get there? This is simply and for is so this is py 4px is the numerator, so it becomes 4px py. 4px times m gives you 4pxm. Py times this gives you py square. So that's how we are able to get onto this. So look out for the next video on how to derive indirect utility function.